IB maths is easy.
By the sum of the first 5 terms, so they ask for S5. So it will be 5 squared plus 4 times 5, which is 45. Given that x6 is 60, find u6. So u6 will equal with x6 minus s5. So 60 minus 45 will be 15. Now find u1. So we know that u1 will equal with s1. So it will be 1 squared plus 4 times 1, which is 5. Okay, now they ask for the general term. So we have we have u6. We have u6 equal with the first term plus 5 multiplied with the common difference. So it will be 15 equal 5 plus 5d. So d will be 2. So the general term will be un equal with u1 plus the common difference multiplied with 1 and minus 1. So put the number in. So 5 plus 2 multiplied with n minus 1. Okay, d. V2 is U1 and V4 is U6. So we have V2 equal with 5 and V4 equal with 15. So we have V4 equal with V2 times the common ratio square. So R square will equal with 3, which is 15 divided by 5. So R will be positive or negative square root of 3. Okay, given that V99 is smaller than 0. So V99 will equal to V2 multiplied with R power 97, which is smaller than 0. So 5 multiplied with R power 97, smaller than 0. So this one must be negative. So the common ratio must be negative square root of 3. Now they ask for V5. So V5 will equal with V2 multiplied with R power 3. So 5 multiplied with negative square root of 3 power 3, which is 5 multiplied with 3 multiplied with negative square root of 3. So we have negative 15 square root 3. Question 9. At t0, the object as origin. Okay. Find the displacement when t equal 1. So given the velocity, so to find the displacement, we must integrate this one. So st will equal with the integration of vt dt, which is negative t4 over 4 plus 7 over 2 multiplied with t3 over 3 minus 2 multiplied with t squared divided by 2 and plus 60 plus c. But we know that at t0, the object at origin, so c is 0. So simplify. So negative 1 over 4 multiplied with t power 4 plus 7 over 6 times t cubed minus t squared plus 60. Now they ask for S1. So we sub t equal with 1. So it will be negative 1 over 4 plus 7 over 6 minus 1 and plus 6. And it will be 71 over 12 meter. Okay, now find the acceleration. So the acceleration is the first derivative of the velocity. Okay, derivative of the velocity. So we have negative 3t squared plus 7t minus 2. Okay, find the greatest speed reached by the object before it comes to rest. So the velocity comes to rest when the velocity equals 0, which is here. So find the largest velocity here, which also the greatest speed. So it will be this local maximum. So to find the position of this local maximum, we must give the acceleration equal 0. So this one equal to 0. So let's change the sign to make it easier to solve. So 3t squared minus 7t plus 2 equals 0. Okay, it will be 3t here, t here. Let's solve this one by grouping. So multiply equal 2. So negative 2 here, negative 1. Let's check negative 6, negative 1, negative 7. So correct. So t will be 1 over 3 and t will be 2. We notice that this one is the local minimums and it comes first. So this will be 1 over 3. 1 over 3 will be here and 2 will be here. So the greatest speed, the answer for C will be V2. So we put 2 into this function. So it will be negative 2 cubed plus 7 over 2 multiplied with 2 squared minus 2 times 2 plus 6. And we will have 8 meters per second. Okay, D. Find the greatest speed reached from 0 to 4. Okay, so speed will be the absolute of the velocity. So which one has the greatest distance away from the x-axis? So it must be here, when t equals 4. So we must find the absolute value of V4. So put 4 into this one. So the absolute value of negative 4 cubed plus 7 over 2 multiply with 4 square minus 2 times 4 plus 6. Don't forget the absolute value. We will have 10 meter per second. Okay, write out an expression that represents the total distance traveled while the speed is increasing. Okay, in order for the speed in increasing, the velocity must be positive and going up, or negative and going down. Okay, so it will be from here to here and from here to here. So t here is 1 over 3, t here will be 2, t here will be 4, and this one will, let's say, is a. Okay, so an expression for the total distance traveled will be the integration from 1 over 3 to 2 of the velocity plus the f, because this area is under the curve, so it will be negative. So this one must minus the integration from a to 4 of the velocity dt. And we are done.